Good afternoon to all of you. Good afternoon, all of you. All of you, please confirm my voice is clear to all of you. Okay. So in the last class, in the Maha revision class, we have discussed all the chapters. सुपर 20 और महाअभ्यास पीपीटी में अभ्यास लिखा है. ओ अरे इट्स अ मिस्टेक. थैंक यू फॉर करेक्शन समर्थ. इट्स मिस्टेक बच्चा. So no problem. In the class notes part I will correct it, but right now it's super 20. Okay, so it's just a simple typing mistake. Okay. So any doubt or any query which you want to discuss, or directly we'll go for the numerical. Any doubt or any query if you are having first, you can tell me, or else we'll go for the discussion. Or else I will go for the discussion. Directly numerical? Okay. So first of all, I think it is clear to all of you that in this Super 20, basically we solved 20 questions, which is a PYQ question. But first I will ask those questions to you, which is actually like maybe Tiger have asked some doubt or Ankit have asked some doubt. So I will discuss that question first so that all your doubt will be cleared, and then the remaining PYQ I will discuss. Is that okay? Is that okay to all of you? So first I will discuss the doubt which you guys have asked. Let's start with that only. This question, I think, from you only. Someone have actually asked this question. Answer. Who asked this question? Is that person is here? A rectangular channel with a gradually varied flow has a changing bed slope. If the change is from a steeper slope to a steep slope, the resulting GVF profile is. This question they have asked in GATE 2022 for 1 mark. For 1 mark. If you see the situation here, what they have given you, steeper slope to steep. Steeper slope to steep. In first case, steep, that means somewhere here you will have the NDL, and somewhere here you will have the CDL, because in steep part CDL will be on the top, NDL will be below. NDL will be below. Now, as you are going from steeper to steep, that means you are actually increasing the slope or decreasing the slope. I want answer from you guys. You are actually increasing the slope or decreasing the slope? Comment. You are increasing the slope or decreasing the slope? Decreasing the slope. So if you are decreasing the slope, depth has to increase or decrease. The water surface profile which will be there from the steeper to steep, it will be a rising water surface profile or a falling water surface profile. That only I want from you. As I said, this type of question you have to answer with a basic logic which I told you. Only the basic logic is useful. It will be a rising flow or it will be a falling profile. You are actually decreasing the slope. So if you decrease the slope, the depth has to rise. And if depth has to rise, it will be a rising water surface profile or a falling water surface profile. Rising. Now look at what you guys are answering it. Many of you are answering S2. S2 is a rising water surface profile or a falling water surface profile? S2 is a rising water surface profile or a falling water surface profile? Yesterday also I told you, if you don't know the 12 water surface profile, their nature, their characteristics, in that case doing this type of problem will be problem for you. S2 is a falling water surface profile. So S2 is not an option here. It is a rising surface profile that is going to come. Now in rising water surface profile also you have an option of S3 and S1. S3 and S1. S3 start from the channel bottom and S1 start from the above the CDL line. Above the CDL line. Now, if in this section, do you really think the transition part, the water level can rise above this situation? Just your thinking I want. Or instead of that, the water level will rise from here, somewhere from here. Like this. Now this one, if it goes like this, that is a case of S1. If it goes like this is a case of S3. Now, after knowing all this concept, I'm asking a basic question to all of you. Once again, I told you, to solve this type of problem, you need to know the 12 water surface profile, you need to know the basic characteristics, and then small common sense is also required. If the water is coming from a steeper cross section, it will rise like this. It will rise like this. You will find here you will find that your y is lesser than the critical depth. That means here you will get a small hydraulic jump type of situation. So it is going to be the S3. It is going to be the S3. Your answer will be A. I think only one student has answered correctly for this question. Now tell me, was this question difficult for you? Frankly speaking, I want an answer from you. Was this question difficult for all of you? I want an answer from all of you. If somebody, I'm just showing you slide of the paid batch class, those students who have attended the open channel flow class, these are the slide. Steep to steeper, steeper to steep. Now, if anyone here, if that person is from paid batch, is it from class notes or not? This question was directly from class notes. So somebody who have revised the class notes, definitely that person got the maximum marks for this question. If anybody is here, if anybody here is in paid batch, that person can tell you. Okay. Like this, only one more question they have asked. Somebody who have remembered the data itself, in that case, you have to wait for other. A very wide rectangular channel, that means simply it is a R equal to Y type of situation. Carries a discharge of 70 meter is per minute width. So that is 70 meter cube. It's a typing mistake. Meter cube per second per meter. Its bed slope changes from 0.0001 to 0.0009. Okay. Mild to steep, as shown in the figure. The Manning's roughness coefficient of channel is 0.01. What water surface profile exists near the point P? Near the point P. Now, somebody who will try to solve each and everything, if you see this question, mild and then steep. So definitely in the mild, after that mile you are having more slope, so the water level is going to fall. If water level is going to fall, so it will be a M2 profile. Now in the steep, again falling only, so it will go like this. So to show this in detail way, first you draw the critical depth line. This was the CDL for you, this was the NDL for this. So this will be M2, this will be S2. So without even solving, we got the answer. Clear hai? And that's the reason many of you have already answered this. Okay. One more problem, I think you guys, you guys discussed this problem a lot in the Telegram group, I have seen. Try this question. Acha, in this type of section, it is mentioned mild and steep. That's why it's easy to do. Otherwise, you have enough data also to check that. You can find out YC here. Just for a, you got the answer, but so YC will be Q square upon G, which is 70 square upon 9.81 to the power 1 by 3. Like this, you can find out the YC here. And then you will have normal depth also. By using the Manning's roughness coefficient, you can calculate the normal depth also for this situation and this situation. For both the situation, you can find it out. And then you can check whether it is a mild slope or steep slope or not. So that also you can do. Now this problem is something like when it came in 2023, many of you guys are not able to solve. I can understand the reason why. Because in our GATE syllabus, we generally don't discuss the combined cross section. If you use your logic, in that case you will get the answer. But generally we don't discuss the combination of. This is basically a combination of section. We can call this as a compound system or compound section. Anybody? Any guesses or anything like this? Compound section generally we discuss when you go for water resource engineering masters. There we discuss the compound section a lot. During my master, actually, I have studied these things. So in a compound system, this side you are having the Y, and this side you are having the specific energy, E. A small curve I am making it for you. After making that curve, then you can understand this problem easy. This is the flood plane. And that is a depth Ym. That is a depth Ym. Okay. Gamer PUBG is telling sir, not able to understand what they are actually asking. You know the concept, only the application part you don't know, because I know this question was a little bit out of the track, but we can try. We can try with the basic knowledge what you are having for the critical flow. Now, what they're asking you here, as it is a compound system, they want maximum number of critical depth which is possible. That is something what they're asking you. What they have given you, BM is the bottom width of the main channel. This was the main channel here. So this is a cross section of the channel. If you notice in this cross section, here we are having different Manning's coefficient, NM. Here we are having a different Manning's coefficient, that is NF. Here we are having a different Manning's coefficient, that is NF. Here we are having a different width. Here also we are having the different width. Now, Ym is the which is the depth which is given to you, depth of the depth of the main channel, and Y is basically called as the total depth of the channel. That means currently the flow is at this point. Currently the flow is at this point. All the term is known to you. Now my question is to all of you. See, here they are asking only one cases, but I'm going to explain you 3 cases, because maybe in future if someone if they have asked question based on this topic, you guys will be able to solve this. Now see here, you only will tell me. Now if flood is not going on. Normal flow is going on. So during the normal flow, only the main channel will be involved. Yes or no? Because this channel is having some depth, na? This channel is having some depth, na? So this part of the cross section will be involved only when you have some floodplain type of situation or extra flow type of situation. In a normal flow, you will have only this part in a working condition. Am I right or wrong? In a normal flow, you will have only one part in a normal condition, that is nothing but the main channel. Do you all agree? Do you all agree for this point? Basic discussion. Whatever it is, rectangular, square, whatever cross section it is, but during normal flow, only this part of the channel will be in a working condition. Na? Now you only will tell me that is the first case for you. That is the first case for you. During that first case, how many number of critical depth possible? How many number of critical depth possible only when main channel is working? And that if I want to draw here, it will be like this. YC1, this is your C1 point. YC1, this is your C1 point. Only one. Only one. Okay. Now go to the next case. Go to the next case. Now once complete flow is going on. Now in that section, do you really think more than one number of critical depth will be possible? The reason why I am saying it, because sir, now here we are having a different Manning's coefficient. Here we are having a different Manning's coefficient, that is Manning's roughness constant. Here also we are having a different than the main channel. So there will be a chance that different discharge, and in that case you will have different number of or more than one number of critical depth which will be possible. More than one number of critical depth is possible. That is, I want something from you guys. Now, the same thing if I want to draw you here, situation what I'm telling you is that when sir floodplain came, now the complete area will be the flooded. Now the extra flow is going on. In that case, what they will notice, you will have a different type of something greater, or let me make somewhere here. This is for a different discharge, which is definitely more than this Q1 part, which was the initial discharge. Okay. Now, in the combination phase, what we will find, in the combination phase that is in between, you will notice three type of random figure I am drawing to you. And this is a standard figure, so that is the reason a random figure I am drawing to you. One is the C3, in between the C2 and the normal was C1. And this discharge is Q2. So Q1, Q2, Q3, if you see right side you are shifting it, so Q1 will be lesser than Q2, Q2 will be lesser than Q3. That is a case that we need to understand. They are talking about the maximum critical depth possible. So maximum critical depth will be C1, this one, then C3, and in between this we have a C2 also. Clear regarding this? What if there was no symmetry? First of all, understand, I'm not talking about a case which is there related to this part. What I'm talking about, these are the cases which will be possible. If your flow is only under this, only one critical depth point you will find. If you are having more discharge, very high discharge, in that case again you are getting only one critical point. Critical point, that means maximum discharge point or minimum specific energy point. Now, if you are having in between the discharge Q1 and Q3, you are having the 3. Actually, C3 and C1 exist, and between this, we are having a C2 also. So that is the reason we have made this type of curve. And it is not related to the symmetry part. It is not related to the symmetry part. That means you will say, sir, here if you are having a different width, here also you are having a different width. In that case, the value can change, but not the situation, not the concept. Is that clear? Value wise it can change. YC1, YC2, YC3 can change, but situation wise it will not change. Like your YC1 will be always less than YM, lesser than the floodplain. That is completely true. Even though if you are changing the symmetry and all, your YC3 will be more than YM. That is also completely true, irrespective of what cross section you are having. Now, once again, as this is a part of your question, that's the reason I have discussed. Still, I have not included this part, combination or compound symmetrical opine channel, in our course. But if you guys want, I will include this for future discussion. What do you think? Should I include this? Reason why? Because only 1 year they have asked, and generally we don't include in our syllabus until unless they asked 1 or 2 times more. Actually, it's a part of your master course. When you'll go for master in water resource engineering, then you have to discuss this compound channel in detail. Here I have told you directly, this you have to make it also. By taking data and all, you have to make these things. Right now, the graph I have given to you. Okay, so right now they have asked you about the maximum one. So that's the reason 1, 2, 3. Your answer was 3. If they will ask the minimum one, then our answer will be 1. Clear? Clear to all of you? Okay, so this question I think many of you have asked me. That's the reason I have discussed. Telling this much detail in Telegram is difficult, na? So that's the reason I have discussed it here. Achha, one more question. I think this also someone has asked. This question also someone has asked. Is it the right problem? I'm not able to type it properly, so I am using the screenshot here. Who have asked this question? Who have asked this question? सब सर के ऊपर से जा रहा है, हाँ, तो अभी मैं कुछ कर भी नहीं सकता बच्चा, ये रेगुलर क्लास तो है नहीं ना। अगर आपको चीजें समझ में आ रही होंगी तभी जब आपने रिवीजन क्लास किया है, रेगुलर क्लास आपने कंप्लीट किया है ओपन चैनल फ्लो का, क्योंकि अभी जो लास्ट प्रॉब्लम हमने अभी किया वो रिसेंट ईयर में सबसे डिफिकल्ट प्रॉब्लम में से था। ये बात नॉर्मली बच्चे सोच नहीं पाएंगे, तो वो बहुत सारे बच्चों ने उस क्वेश्चन को या तो स्किप किया या गलत किया, तो दैट्स कंप्लीटली ओके। कई बार तो एक दो बार तो गेट थोड़ा सा अपना लेवल बढ़ाएगा ना, ऐसा थोड़ी है कि हमेशा आपको आपके अंडर ही आंसर देगा या आपके अंडर ही क्वेश्चन देगा। ओके, ट्राई दिस क्वेश्चन नाउ फॉर इंग्लिश, नो हिंदी। अरे दैट पर्सन इज आस्किंग ना, suspicious. First of all, your name is something which I'm not able to pronounce. Try this question. Try this question. Okay. Reservoir A and B with a water level of 72 meter and 57 meter respectively above datum are connected to a junction J. So J was the junction. Three reservoir A, B and C. A and B, okay. Junction is located at 43 meter above datum. So this is 43 meter above datum. So they have given you the datum head. And for reservoir A and B also the water level. So there also they have given you the datum head, okay. The pipeline parameters are this point, first of all name it J. AJ 400, BJ 800, CJ, so all the length they have given you. Friction factor for all the pipe is same. If the pressure gauge at junction which reads 90 kilonewton per meter square, so here the pressure is 90 kilonewton per meter square which is given to you. Determine the discharge in the three pipe and also the water surface elevation in the reservoir. C, neglect all the losses. Okay, so it is very easy question. The first thing what I want from you, tell me the piezometric head at junction J. Piezometric head means pressure head. Pressure head is 90 kilonewton per meter square divided by its water, so 10 to power 3, and the G value they have not mentioned anything na, so I will take 9.81. Okay, and the elevation head is 43 meter. So piezometric head at junction J, how much you guys are getting it? Piezometric head at junction J, how much you guys are getting it? First thing first. According to Kushal, 52.174. Now here we are having a piezometric head of 52.174, and for A and B they have already given you the elevation head of so water surface elevation. That means the pressure will be 0. So the total piezometric head here will be 72, 57. They want to find out discharge. So one by one I will find it out. Let's first talk about AJ. For AJ, the head loss will be, there it is 72 meter minus, here it is 52.174, and I'm considering only the friction losses here. So for that reason, F is given to you. So F is F into L into Q AJ divided by 12.1 dAj to the power 5. Now according to the question, if I go 72 minus 72 minus 52 minus 1.74 is equal to the value of F we are having. Friction factor is 0.02, which is given to you. Lengthwise it is 1000. AJ is 1000. Discharge FLQ squared. So discharge is something I want you to find out. Divided by the diameter is 12.1 into 0.4. So I can expect all of you to give me the QAJ value in meter cube per second. First part. Tell me all of you quickly. QAJ square I'm asking. It is 0.02 into 10 to the power 3 into QAJ whole square. QAJ, different answer I am getting. Single answer I want from you guys. Okay. Till then you all guys are giving me the answer. I will go for the another one. B to J. For B to J, the head loss is basically, here it is the total head is 57 because the pressure head is anyway it's 0. 57 minus, here the piezometric head is 52.14. So 57 minus 52.134 equal to, again, F value is 0.02. Length of BJ is 750 meter into QBJ whole square divided by 12.1 into DBJ. BJD is 800 mm. So that means 0.8 to the power 5. So I can expect all of you to give me the BJ value in meter cube per second. In meter cube per second. सर पीजे के कैलकुलेशन में 90 कहां से आ गया? हाँ, वेरी गुड अमर भैया. In this PJ calculation, what we are doing it, we have the pressure value also, na? At this junction we have some pressure. These 3 points are open to atmosphere. So if these 3 points which is open to atmosphere means what? They will have what? What pressure? Gauge pressure will be 0, na? Completely atmospheric pressure. So gauge pressure will be 0. But if these 3 tanks you have connected and that is connected to a junction J, that junction you have some pressure which is given to you. You have some pressure which is given to you. Is that clear? The 43 which is given to you at junction J and all, whatever it is, value of Pj incorrected value is incorrect of Pj, corrected value is 43.009. Okay, is this wrong? Is this wrong? Oh, is this wrong? Are it's a kilonewton na, so that person who has given it's right only. It will be definitely more na. Now see this. Simply copying paste will not help you. So those who have answered 52.174, I am hoping it will be greater than 43. It will not be near to 43. That is for sure, I know. I am not calculated this, so I cannot say this is right or wrong. But definitely it will be more than 43. You guys have not included the kilonewton part. Am I right? Given data. Okay. QAG and QBG, both I want quickly, and a simple answer from all of you. Those who have solved both QAG and QBJ, both answer I want from you guys. Both answer I want from you guys. And a single answer. Don't confuse me between two values. QAJ according to Ritika, it is 0.35. QBJ according to you guys, BJ we are getting 1.134. Very high. Is it right? QBG we are getting 1.134. Again very high. Check, everyone check this. 1.134 is very high value, man. If you all are getting the same, then I will take that only. But right now I want you to recalculate this. Right now I want you guys to recalculate this. Okay. This much high we are getting the discharge. Let me calculate this. Diameter is wrong. Diameter is 800 only we have taken, na? 800 only we have taken, na? Oh, here it is given 300 mm. Here that person done the typing mistake then. So you guys are answering, I think, according to the dia. So according to 800, maybe it will be the right answer. We can take 800 also, no problem. Now how much you guys are getting it? According to my calculation, I am getting around 0.097. Now, when it comes to the third part, what they're asking you finally in this question is that determine the distribution of discharge in the 3 pipes. So in 2 pipes, we have calculated this. Third pipe we can calculate. So third pipe it is nothing but QCJ. As you can see here the total head is 72. The flow is going like this. From here also the flow is going like this. So definitely at the junction, after meeting this 2 flow, it will go in this direction. The flow will be from J to C. The flow will be from J to C. So total discharge will be 0.35 plus 0.097. Whatever you guys are getting it, that will be the right answer. Then they are asking another thing also. They are asking and also the water surface elevation in the reservoir C. That means just like these two, they want elevation for this also. No problem, we'll do that. Piezometric head at J minus PC or elevation head at C will be equal to again F 0.02. What about length? This time we'll take length from here only, or we'll match both the data. So length is 850 at both the places. So FL into Q already we have. So directly write the data. After summing it, 0.447 na? Zero 0.447 12.1. Diameter is 600 mm, so it is 0.6 to the power 5. Now PG is something which is already you have. It is 52.174. I want EC, elevation head at section C, or elevation head at container C. And whoever asked this question, is it clear to all of you, my dear? Is it clear to all of you, my dear? Is it clear to all of you, my dear? .564, as you all guys are suggesting. 48.564 meter. So this question actually, what I'm assuming it, Ankit has actually asked this question. So I think he has asked a question related to, that was a 1 mark question. So because of that only, I have taken you a bigger problem based on the same concept, so that if you understand a bigger problem, solving a small problem will be very easy for you. So recently, I think 1 or 2, 3 years back, they have asked, or maybe 4 or 5 years back, they have asked a question based on this concept only for 1 mark. If I'm not wrong, Ankit actually asked the same question. So now after solving this complete question, clearly you can solve that question easily. That was actually 1 mark question, only telling the discharge part. Only telling the discharge part. And this is also a gate PYQ only. It is actually in 90s they have asked this question. So that time they used to ask for 5 mark. Okay, another question again. This question also someone from you from student community only. They have asked me in the telegram, and that question also disturb you a lot, but I don't think so. Especially for sincere student who have practiced a lot, this type of problem is not a difficult problem for them. Try all of you. Any data if you find not typed properly or something like that, you can tell me. Here it was written water, this was oil, and this was again water. Anybody got the value? What they want? They want the total force due to pressure on the side PQR. This side they are talking about. This side they are talking about. So total pressure force they want you to calculate. So the point we are having R, then somewhere here we are having Q, and then somewhere here we are having the P. What I want from you guys is the pressure at these 3 points. Can you calculate? Pressure at R, pressure at Q, pressure at P. These 3 value I want. Pressure at R, pressure at Q, and pressure at P. How much you will get the pressure value? First of all of you tell me whether you guys need my help or you guys are solving it. If you guys are solving by your own, in that case, I will not help you. I will wait for your response. My voice is clear to all of you because I'm not getting the response. My voice is clear to all of you. Like if I have to find out pressure at R, again basic logic which I told you in the fluid statics class also. If you are at this point, it is open to atmosphere. The specific gravity of oil is given to you as 0.8. These are the two data which is mentioned to you. First of all, if I have to find out pressure at point A, I will start from here. Let's take this point. So 0, which is the gauge pressure or atmospheric pressure, you can call it as. Now this water pressure will be 8 plus 2, 10. So it will be rho W is already given to you as 10 kilonewton. So 10 into 10 to the power 3 gamma into H. H is basically water, that is 10 meter height. Okay. Now I am here. Now if you notice, same level of water depth you are going down, and then again same level you are going to increase it also. So down, that means plus, up again the minus. That means at this point and this point the pressure is the same only. So I'm not including that. One time you have to do the plus, another time you have to do the minus. 4 meter you are going down in the water, again 4 meter you are going same in the same liquid, water only. Now from this point again directly I am here. Then R is at somewhere 4 meter above but in oil. So minus, oil specific gravity is 0.8 into 10 to the power 3 into height is 4 meter, which is given to you. Okay. Now I want from you, tell me the PR value in kilo Pascal. I want the value in kilo Pascal. फाइनल आंसर क्या है समर्थ, वो तो सॉल्व करके देखेंगे. अभी पीआर क्या आया सब बताओ. अगर सब लोगों ने सॉल्व कर लिया हो तो अपना पीआर बता दें कि पीआर कितना आया. प्रेशर एट पॉइंट आर. 68. What about PQ? For PQ, as I told already, at this point and this point, the pressure is the same. So it is nothing but going to be 10 into 10, 100 kilonewton per. So 10 into 10, so it will be 100 kilopascal. What about PP? First you are going 10 meter up to this. Then again you are going down for 5 meter, not 5 meter, 6 meter. 4 plus 2, 6. So 6 meter again in water only. So total pressure at PP will be total 16 into 10. That means 160 kilopascal. If you are able to find this, then half of your work is already completed. Now I will simply draw the diagram for you. Which diagram I'm drawing this? This is a pressure diagram. This is a pressure diagram. So this is 100. Okay. This is 68. This is 100. This is 160. And this is your pressure diagram. This is your pressure diagram. Now to find out force, what you do? To find out force, what you do, my dear? To find out force, what you do? You just find out the volume of this pressure diagram. You just find out the volume of this pressure diagram. To find out force, half into RQ height is 4. So 4 by 2 bracket 100 plus. So this is 168 plus. PQ is 6. So 6 by 2 into 100 plus 160. So F value, they have given you something width and all? No, they have not given you the width and all. Na? Is it given? 5 meter into 5 meter closed tank. So I think this tank they are talking about. Na? So 5 meter into 5 meter. So width is given. Width is given. So you have to multiply that also because you need volume. Na? Tell me the value. Tell me the value. Final value. Basically, we have made a pressure prism here, and then the volume of pressure prism is going to give you the total force. That only we are calculating. That only we are calculating. 5580. 5580 kilonewton. Now tell me, was this question difficult for you? Because nobody has answered me this. In the first attempt, nobody has given me the answer. After attending class also, if you are not able to find out a pressure prism or pressure at any particular point, you know why only? If somebody you are not able to find out, it is only because you have not solved at least 10-20 problem, especially from pressure prism. You have not practiced that part. Otherwise, this question is not a difficult problem. Okay. I will give you one more question. Try this question. No, literally, sometime I generally reply to all the doubt in Telegram. I try to reply, but sometime like this question, why I have given you last question, why I have given you. Few days back in my Telegram group, one student has asked. Look at his question. That clearly shows that he has not attended class, or maybe he was completely out of zone at that point. Sir, here the pressure is whatever pressure at the bottom. Why you are equating with the pressure at Q? That was his question. That clearly shows I may be soft to you, I may be hard to you, but hard things is going to help you. That's why I'm telling hard things to you. If you actually forgot this thing, that means you actually forgot the complete fluid statics chapter. You have to revise the chapter again. You have to revise the chapter again. It is a hard fact, but you have to do. Somebody who is telling, sir, why here and here the pressure that person in solution has taken same? Because if you are going down in the same liquid and then again come back with the same liquid, that means first you are adding the pressure, then you are subtracting the pressure. The addition and subtraction both in a same liquid, of water. So in that case, we can take this. Many times you guys have taken for this type of setup, many times you guys have taken the red line concept. Why we take a red line here? First of all, it is passing through an interface. Second thing, we try to cancel this part. Same type of liquid only you can cancel it, not two different type of liquid. So that if you are going down and then again you are going up, both are same only. That's why at this point, in this point, we take the pressure same. Very good, Abhinav. It is a red line concept. So if you forget this, then that sometime I also get hurt, if you ask this type of doubt. That clearly shows that person or that student actually not revise the fluid statics chapter itself. And then you will say, sir, fluid mechanics problem is difficult. Try this question, bacha. we as a faculty now also motivate, like we also get motivation through your doubts. If you keep on asking the good doubt na, that actually motivate us also. Like just an example I'm giving to you. I'm not quoting someone. Like yesterday after this long session, after a long session, I was completely fed up. Like energy wise, completely down. Still, I have answered a doubt, only the last answer that I have done it. The reason why, look at the doubt. Look at the doubt. Sir, within the boundary layer region, laminar flow through pipes. Within the boundary layer region, then laminar flow through pipes and turbulent flow through pipes. In तीनों cases में, it is in Hindi, it is in तीनों cases में हम only viscous and pressure force consider करते हैं. Why we neglect gravity? Why we neglect gravity? So I took 5 minutes to explain this to that student, but actually that type of doubt na relax me. Whatever stress or of teaching or whatever mental stress we are having, that get relaxed after seeing this type of thinking from your side. By the way, if I ask this question to all of you, what will your answer? What you guys will answer? You have understood the question now? I'm going to tell you that part in English, which that person has told. Within boundary layer and the laminar flow through pipes and turbulent flow through pipes, in all these three cases, we take only viscous force and pressure force for the discussion. Why we neglect gravity forces? Why we neglect gravity forces? What will be the reason behind this? What will be the reason behind this? Yeah, what you guys will reply if someone will ask you this question? In the discussion of laminar flow, you have seen we have taken the pressure forces, we have taken the viscous forces. Viscous forces is taken because laminar flow is completely viscous flow, so you can consider that as a viscous flow, and pressure force. Why we have not considered the gravity part? Why we have not considered the gravity forces? All of you think about this. Answer is very simple, but thinking in this direction actually motivates me. Answer is very simple. Somebody who will answer it, it is actually very simple question. If you notice, let's an example for laminar flow. If you guys remember the derivation for laminar flow, we are talking about x-axis or y-axis. The derivation part which we are doing it, the flow is happening because of the difference in the pressure, because of the pressure gradient, and in this direction, in the flow direction we are talking about. We are not talking about the vertical. So in the flow direction, the flow is due to the pressure differences, and definitely the resistance is given by the viscous forces. Then if you talk about something in a vertical, then the gravity force will come in contact, na? Or then the gravity force will be important for you, na? If you remember the laminar flow circular pipe discussion, we are talking about along the flow. So along the flow, only two forces is more important for us. One is the pressure force, because of the pressure gradient only the flow is taking place. Another is what? Second thing is what? Is the resistive force, which is given by the viscous force. That's why only these two forces are included, and you are talking about along the axis. So vertical force will act across the axis, or in a transverse direction you can call it as, and we are not analyzing in a transverse direction. So gravity force effect will come when the pipe will be vertical. Gravity force effect will come when the pipe will vertical. So if pipe is vertical, then gravity force effect will come. But situation is generally in that situation also we neglect the gravity mass part because lesser importance for us, lesser effect. But yes, effect will be there. If pipe is in vertical direction, in that case gravity force will be also comes in the picture. Now this was the answer. Okay. Regarding this question, I think all of you have answered correctly. This question is actually not fluid mechanics question. This is actually a physics question. A fire nozzle direct a steady stream of water of velocity 50 meter per second at an angle of 45 degree above the horizontal. So this is actually a projectile motion question. I think you guys have solved this type of question in your 11th, 12th class physics. This angle is 45 degree which is given to you. Okay. Above the horizontal. The stream rises initially but then eventually fall to the ground. Because it will go like this. Projectile motion. This is the ground. Assume water as incompressible flow and inviscid. So we have density 0 and the viscosity also they are not considering it. Consider the density of air and the air friction as negligible. So they are neglecting the effect of air density and all. And assuming the acceleration due to gravity as g 9.81 they have taken. What they want from you is the maximum height reached by the stream above the hose nozzle will be then. That is what they are asking you. This part. So if you remember the three basic equation, if you remember, it is v square minus u square equal to 2s. I'm applying this equation in this direction, in y direction. So at this point you are having the final velocity as 0 because at this point the maximum velocity, or you can call it as the instant velocity at that point, will be 0. Minus you have to find out. It is 5 sine 45 whole square equal to g is 9.81 into s. This s distance is s only. So can you guys give me the value for s? By the way, it is going up, so g will be also minus only. With a g, it will be a minus. So this minus and this minus will get cancelled out. You will have 5 sine 45 whole square divided by 10 into 9.81. So calculation wise, you can give me the answer. $63.71. Now, if I will ask all of you, tell me, is this problem related to fluid mechanics concept or is this problem related to your 11th, 12th basic physics? In this question, they have asked for 2 mark. This question they have asked for 2 mark. Try the next question. Acha. This was 50. Oh. Sorry. Mora maaf karo. This was 50. Okay. Try the next question, bacha. 2 point you can take it as. This point is 1, this point is 2. If I will ask you to find out pressure at difference between point 1 and 2, so how you will do this? This gap is not given, so I will take this gap as x. Up to this you are having mercury, which is the manometric fluid. Up to this you are having the mercury. Okay. So if I will go through the basic, so basic wise, I will draw a red line here. I will draw a red line here. This point and this point I am calculating the pressure. So it will be P1. Then you are going with the same liquid. Water is flowing na? In that, water is flowing. So P1 down, so rho W into G into distance wise it is 0.15 plus X. Then for this side if I calculate, it is P2. Then again in water we are going 30 plus X. So plus rho W into G 0.30 plus X. Okay. Then some part of mercury also is involved here. So rho Hg into G and mercury is 0.15. Okay. What I'm interested in P1 minus P2. I'm interested in P1 minus P2 and divide by rho G. So the remaining part I can write down like this. P1 minus P2 divided by rho G equal to. This part will be completely 0.3 minus 0.5. Here this part will be 13.6 into 0.15. Am I right? I don't think so anybody will have any doubt here. Let us 0.15 bracket 13.6 minus 1. Am I right? So it is 0.15 into 12.6. You can give me the value here in meter. 0.15 into 12.6. You can give me the value in meter. How much you got? How much you got? Now, this is the basic way how you can find out the pressure difference or how you can find out the H value here. Another way is something which I gave you in my class also. You can directly use this when the deflection in the mercury manometer is given to you as 15 centimeter. That is the manometric reading for you. So manometric reading if you are having, and it is a differential type of manometer, I can directly go with the H part. So it will be delta H Sm upon Sf minus 1. This formula I gave you already. So if you remember the formula, directly you can go with the concept. It will actually reduce the calculation part. So 13.6 divided by 1, 0.15 into 12.6. So the H value, here also you are getting the same, 1.89. So that is the reason in my class I have given you this formula. So this formula came through the basic concept only. I told you the basic concept part also and the formula also. It's up to you which one you want to try. Okay, so now if you have the Q value, Q theoretical they want. So basic formula will be A1 A2 root under 2GH divided by under root A1 square minus A2 square. So Q theoretical will be equal to what? A1 A2. Now A1 A2 what they have given you? Measure to the pressure of flow water in a vertical pipe of 20 centimeter diameter. So D1 they have given you 20 centimeter and throat diameter they have given you 10 centimeter. Okay. So that you have to find out by my dear, which is pi by 4. D1 is 20 centimeters. So 0.2 whole square into pi by 4. D1 is D2 is 10 centimeters. So that is 0.1 whole square into under root 2 into G value. How much they have given you? 9.8 into H. You guys are mentioning 1.89 under root A1 square, that is pi by 4, 0.2 whole square minus A2 square pi by 2, 0.1 whole square. So after solving, I think all of you guys have already given me the answer. How much? According to Kushal, it is 49.4 liter per second. What about other? This question was easy, na? Directly formula based question. Still only one answer I got. Why? Only one, that too from Kushal. Only one answer. Tell me whether Kushal has given right answer or wrong. You guys have to verify this. You guys have to verify this. This is directly formula based question. If you are getting a question from Venturi meter, it is actually easy question for you because you know in what direction you have to proceed. Because you are completely aware that in what direction you have to proceed. According to Avinav, Nehal and near to Kushal answer only 49.93. Clear to all of you? Try another problem. One more, I think, request you guys have done it now. You have asked for it now. You want a question where both the two type of channel transition is okay. So in Mahabhyas session, which is at 6:30, I will give you that question. Right now in this PPT, I don't have that question. So in Mahabhyas session, I will fulfill that request. Drag force Fd on a sphere due to fluid flowing past the sphere is a function of viscosity mu. So they are talking about Fd is a function of mu, viscosity, mass density, which is the rho, velocity of the flow, which is the v, and the diameter of sphere, which is the d. Okay. Pick the relevant non-dimensional parameter pertaining to above process from the following. Now, first of all, I have to select n value, which is 1, 2, 3, 4, 5. Dependent and independent variables. So total n value is 5 here. Next, number of repeating variable I have to select. So one will be from geometrical criteria, another will be from kinematic criteria, and the third will be from dynamic criteria. So in dynamic criteria, you have two options. Either you can go through mu or rho. It's up to you. It's completely up to you. If I'm using rho here, m will be 3. Okay. Now, if I will write the first non-dimensional term here, it is pi 1 equal to, first we are having rho to the power a1, then v to the power b1, and d to the power c1. Here, if you notice, they are actually giving a relation between Fd and all these things. So we have to try that only. Let's try, because only 2 times we can try, one with mu, another with Fd. So let's try with the Fd first, which is a drag force. Pi 1, m0, L0, T0. Density dimension is mass upon volume. So mass upon volume. So ml minus 3 A1. Velocity it is. So it is L by T. So LT minus 1 B1. What about D? It is L only simply. So it will be C1. And what about FD? FD is basically that force. Force is basic formula is force of what? Mass into acceleration. That means m L to the power L into T to the power minus 2. Acceleration is meter per second squared. So L T to the power minus 2. MLT minus 2. Both sides you have to equate and you have to tell me the value of A1, B1 and C1. Can you do this? A1, B1 and C1. This is basically the Buckingham method which I was discussing yesterday, that I am going to give you a question, and with that question only I am going to explain you the Buckingham method. So this is that question. Equate, you will get 3, like you have 3 unknowns, so you need 3 equation also to solve this. You have 3 unknowns, so you need 3 equation also to solve this. How you'll get 3 equation? First, let's m part. So in m part, if I see, it is A1 plus 1. So let me use a new slide here. So A1 plus 1 equal to 0. That is the first equation I'm getting. If I'm equating the power of m, if I'm equating the power of L, it is minus 3 A1 plus B1 plus C1. So minus 3 A1 plus B1 plus C1 minus 3 A1 plus B1 plus C1 plus 1 equal to 0. Third equation, if I equate the power of T, for T it is minus B1 minus 2. Minus B1 minus 2 equal to 0. Okay. First of all, this value will give you A1 equal to minus 1. This value will give you B1 equal to minus 2. Let's put this here. So it will be minus 3 minus 1 minus 2 plus C1 plus 1 equal to 0. So 3 minus 2 plus C1 plus 1 equal to 0. So C1 is also minus 2. So those who are giving minus 1, minus 2 and minus 2, that is the right answer. Okay. Let us put all these value here. So pi 1, which is the first dimensionless number for you, rho to the power you are saying minus 1, then v to the power you are saying b1 minus 2, and d to the power you are saying minus 2 again into ft. So first dimensionless number, which is pi 1, is fd divided by rho v square into d square. Is it the dimensionless number you are having in the option? Yes. Option A. Option A. Clear? Now, we don't know about other options. We'll find out y2, pi 2 also. So pi 2 again, if I will write it, rho to the power a2, then v to the power b2, then d to the power c2. One more variable which is left for us is mu. We'll take that, mu. Again, writing the dimensions m0, L0, T0 for pi2, which is a dimensionless number. Density, it is ml to the power minus 3 a2. Velocity lt minus 1 b2. D, it is only l to the power c2. What about mu? Your unit of mu is kg per meter second. So the dimension will be m, mass for kg, l minus 1, t minus 1. Again equate and give me the value of a1, b1 and c1. I want these three values. So with this problem, actually we have revised the Buckingham method. This is basically the Buckingham Pi theorem. Is this method is clear to all of you now? After solving this question through this method, is this method is completely clear to all of you? All three values are minus 1. Okay, minus 1, minus 1, minus 1. Let us put all these value. So pi2 is equal to, you are saying rho to the power minus 1, v to the power minus 1, d to the power minus 1, d is capital D, na? To the power minus 1, and then you are having mu. So pi2 we are getting mu upon rho vd. Rho vd. So with that, again we are having an option. If you see, it is rho vd by mu. This can be also the right option for you. So I think this question was a MSQ question, because option A and C both are right. Option A and C both are right. Now see, sometime, not always, but sometime, like this complete method you also know, but if you have a complete idea of mini formula which we generally see in a fluid mechanics, then with that idea you can actually find out this option also without any calculation. Like for example, if I give you, have you heard about a non-dimensional term which is Reynolds number? Have you heard about this? And which is the general formula for Reynolds number is rho v d by mu. Here diameter is capital D, so that's the reason I'm writing d by mu. So 1 upon Reynolds number. Reynolds number is a non-dimensional term. So if you do 1 upon Reynolds number, it will be mu upon rho v d. So they have written rho v d by mu. So rho v d by mu is nothing but a Reynolds number, and it is a non-dimensional number for you. It is a non-dimensional number for you. So directly I can pick the option C. Now I have told you in the impact of jet formula, F is equal to rho a v square. Rho into area is pi by 4 into d ka square into v square. Let's take 4 here in this part. So pi by 4 is anyway constant for you. So F upon rho into d square into v square is something pi by 4, which is nothing but the non-dimensional term. So this will be also a non-dimensional term. F upon rho d square into v square. Am I right or wrong? So this is your option A. So but this type of I will say sense will come only when you have a complete set of all the formula in your mind. Then only this type of thing will come. Otherwise you will go with the normal process. Otherwise you will go with the normal process. So I told you both the method. Going with the Buckingham Pi theorem method, and another is going with the formula which you know. Formula which you know. Is that clear? Is that clear, Baba? Okay. Next, which problem I should give? Try this one. Try this one, Micha. Sorry. A 2-meter wide rectangular channel is carrying a discharge of 30 meter cube per second at a bed slope of 1 in 300. Assuming the energy correction factor as 1.1 and acceleration due to gravity as 10 meter per second square. The critical depth of flow in meter is something in rounded off to 2 decimal places they want. Okay. They are talking about the critical situation here, and they are saying that the energy correction factor they have added 1.1. So energy correction factor we add in what component of our total head? If I write a specific energy, it is y plus v square upon 2g. If I will write this in energy correction factor we add in y or in a velocity? In velocity head we add or datum head we add? Something we have revised yesterday also. Something we have revised yesterday also. We add here, na? Y plus alpha v squared upon 2g. Okay. So E equal to y plus alpha v square, I can write it in this way. Small q square divided by 2gy square. I don't think so anybody will have any issue here. Now they want a critical depth, and you know for critical flow, your E will be minimum, specific energy will be minimum, and for minimum, I can do dE with respect to y will be 0. So it will be 1 plus alpha will be outside q square upon 2g, and differentiation of y square will be what? Minus 2 upon y cube. Am I right? Equal to 0. Now here the y is yc actually, because we are talking about critical depth now. So 1 is basically equal to alpha q square upon g and 1 upon yc cube. 2 and 2 are getting cancelled down. Anything remaining? No. Take yc in the left side. So yc will become small q square alpha divided by g to the power 1 by 3. So either you can remember this formula, that whenever you can make this as a formula also, that whenever energy correction factor is given, we'll multiply alpha here with the q. Alpha q square divided by g to the power 1 by 3. To the power 1 by 3. Now with that, now this was the complete small derivation which you can do. If you know the basic where we have to add alpha, while explaining the Bernoulli equation concept, I told you for a non-uniform velocity, we add the energy correction factor and we add in a velocity head part. Now if you find out the yc value for this situation, how much you will get it with that formula? Alpha 1.1 they have given you, divided by g is 9.81. Alpha is 1.1, that means it is somewhere near to turbulent flow. Q square, small q, how much you guys are having? 30 divided by the width 2, so it is 15 whole square. So small q squared by g into alpha to the power 1 by 3. Give me the value of yc, my dear. Sir, for direct formula uses, directly you can use the formula. I am actually not the fan of formula. Formula I don't want you to impose on yourself. So instead of that, I actually go with basic every time. If you are comfortable with remembering all the formula, it's up to you, my dear. But as a teacher, I will tell you the both. I will tell you the basics also. I will tell you the formula also. One second, my dear. Here G they have given 10 meter per second square. So we cannot take the 9. If they have given 10, then we will take 10. In that case, we will not go for better accuracy and all. Whatever they have given you, we'll take that only. Whatever they have given you, we'll take that only. So according to your answer, I can see it is 2.91 and 93. Which one is right? 2.91 and 93, 0.2 difference is there. So which one is right? 2.914 is the right one. Okay. Another question. It is a simple question for all of you. If it is given 10, then we'll take 10. Then we'll take 10 only. If it is not given in the problem, in that case, we'll take g equal to 9.81. If it is given in that case, we don't have to worry. We'll simply take the 10. Okay, so I think this question all of you have answered. See, generally two type of channel we are having. One will be the mobile, another will be the rigid. This is something you will study in irrigation also. In open channel flow also you can discuss this. For mobile, first of all, let's talk about rigid channel. For rigid channel, there will be no change in the shape and slope and all. The only thing you can change is the depth. So only depth is the variable thing for you. Depth of the flow, obviously. In mobile channel, which can change their shape, size and all, you have multiple variables. You have depth, obviously depth will be there. Then you are having width also. Then you are having slope also. Then you are having planiform also. Planiform or tortuosity, or you can call it as the alignment of that river. Sometime that also changes, na? Sometime that also changes. So mobile channel, you are having the 4 degree of freedom. So the right answer, it is a mobile, na? Mobile bit, so 4. So all the questions which is PYQ question, all the doubt mostly which I have found in the telegram that I have discussed. Still, if anybody get any doubt in future, because definitely not all PYQ question I was able to discuss because of the time limit. So, but in future also, if you will get any doubt, my telegram is always open for the discussion. Hydraulic jump occur in 1 meter wide. So width is given to you. Frictionless rectangular channel. So all the formula for rectangular channel which I told you, those formula will be valid here. With a pre-jump depth, that means y1 they have given, and the post-jump depth which is y2, 1 meter. The value of g may be taken as, so g is 10 meter per second square. The value of specific force at pre-jump and post-jump sections are same. The value of specific force at pre-jump and post-jump section are same. Obviously, it will be same. Why need to write? Why to write that? And are equal to. So basically, they want a specific force to you. F is equal to Q square upon G into A plus A into Z bar. As they have not given you the discharge, so first you have to find out discharge by equating to. So Q square upon G is 10, which is given to you, into area wise it is B into y1 it is 0.2 plus area again 1 into 0.2, and what about Z bar? It will be half of this. So 0.2 divided by 2 equal to Q square upon G is 10 into area, this time it is 1 into 1, width is 1 now, okay, plus 1 into 1 which is the area into 0.1 divided by 2, or not 0.1, it is 1 into 1 divided by 2, y2 is 1 now, okay. So first of all give me the value of Q, and then we can calculate the specific force formula. So Q square upon G will do it, but first I need value of Q. First I need a value of Q from all of you. This one is 1.095 according to you. So in that case, 1.095 whole square divided by 10 into 0.2 plus 0.2 into 0.1. You guys can give me the final value. Final value. You can calculate either with the pre-jump depth or post-jump depth. Any, like for both the cases, you will get the same answer. So you can use any of this. 0.62. 0.62. Okay. So till now, if you have any doubt, you can ask me. Next, we'll meet at 6:30. And if you don't have any doubt, then you can tell me that also. Next, we'll meet at next session at 6:30 p.m. At 6:30 p.m. on Gate Wallah MECE channel. In this channel, I will be available to you, or you can get the link in this discussion group also. I will try that in this session, I will not touch those topics which I have discussed in this session. So in that part, we'll have a separate topic. Like today, in this session, I have not discussed channel transition for you. So channel transition numerical problem I will discuss in the Mahabhaya session, because accordingly we can distribute now. Ultimately, if you all have attended these two sessions now, this first session and the second session, so most probably all part of FM and the open channel flow, all important part will be covered, and numerically it will be covered. So in that case, all of you attend the 6:30 p.m. class. There again we'll discuss the questions again, and this time it will be not only the PYQ, I will say some other type of question also I will provide you for your concept clarity. Okay, so excited to meet all of you again at 6:30 p.m. for the numerical discussion. Any doubt or any queries, please let me know, or else we'll end the session. Any query or any doubt if you are having, please let me know, or else we'll end the session. Or else we'll end the session. No doubt? Okay then. Then again we'll meet you at 6:30. Bye bye. Take care all of you. Jai Hind.